few more examples together to make sure we've got the hang of this Pythagorean theorem. So our goal on this first example is to find the length of the hypotenuse in the triangle below. In other words, we're going to find the value of C. So quick review again, just in case. I'm going to highlight the two sides that are legs. So this, whoops, thought I was on a highlighter. It is on highlighter. Okay, so this side is a leg, and this side is also a leg. And we know that when we're using that formula, a squared plus b squared equals c squared, the a and the b represent the lengths of each leg, and the c represents the length of the hypotenuse. So let's go ahead and have the a. Let's substitute the 5 in for a. So that'll be 5 squared. Plus, we're going to use the 12 for the b. So 12 squared equals c squared. So this is an example when you have the two leg lengths and you're trying to find the hypotenuse. So now let's go ahead and solve that equation. 5 squared is 25, and 12 squared is 144. And those two are supposed to equal c squared. And then when I add 25 and 144 together, I get 169. So c squared equals 169. And I'm going to use the inverse operation of squaring a number, which means I'm going to take the square root of 169 to get the value of c. And we know that square roots have both a positive and a negative number as their answer. However, since we're talking about the length of the triangle or the hypotenuse of that triangle, only the positive answer makes sense. So the square root of 169 is c. So that means the length of c is 13 meters. I'm just going to do a really quick check of my work. Whoops. Real quick check. So going back to the original equation, 5 squared plus 12 squared should equal 13 squared if I did everything correctly. So I'm just going to double check it. So that's 25 plus 144 should equal 13 to the second power, which is 169. And it does. So I did verify to make sure that it works.